Hi guys, okay, in this video blog, whatchamacallit, I'm going to try to cover something that has consistently popped up on the FX message boards as it relates to complex character control designs that seems to be, well, let's say, difficult or impossible or improbable to be able to answer with any kind of logical type of solutions to a given problem. As in most cases, the tutorials that are presented are quite easy enough to follow as to, what nodes to add, how to wire it up, and you simply have to follow the design pathway as to being able to accomplish the same kind of results that is being demonstrated in the tutorial. Now, as a primer, it's useful. These types of tutorials are actually pretty useful in that. That as in demonstrating buttons to push, and without having to go into any great depth or detail of what actually is occurring at the root level as to how things are functioning, that can be expanded upon to make a much more complex control system in the designs once you have an addition you want to make that adds to the level of complexity. Now, understandable that I've gone through this myself, and to be honest, I am not any sense of the imagination an expert in blueprint manipulation, but I do understand logic as it is explained to me. So usually when I run into a problem, the first thing I do is just dig out the documentation and start reading the manual, so to speak, to try to figure out, okay, what options are actually available to me. And in most cases, you can do that via discovery by just simply going through the table and looking at something that has some sort of connectivity in the wording as to what it is that you're trying to accomplish. So, for example, well, what the heck is pose all about? How is it used? How does it function with? How can it be made to be used as a function within the animation migration pathway to create the kind of result that I'm looking for? So once you get past the tutorial stage, the design complexity becomes more of a concept, an idea, rather than an actuality of pushing buttons and dropping in nodes and connecting to them. So there are many different ways of being able to accomplish the same task that is limited by what is demonstrated within a given tutorial. You can literally create an entire series based on advanced character design control pathways, that could be literally hours and hours of information to digest. So what I'm going to try to cover is more concept than practical application, based on the need to be able to scale up a design based on that need. So being able to make a character or a player run around and move left and right, there is once again a lot of different variations and options that are available to you, just basically based on the introduction of the blueprint. So to cover the first idea, the first concept that should be understood is what the heck is a blueprint to begin with. So old school way of doing things was as part of a design as to complexity was to sit down and map things out, usually referred to as whiteboarding, or in a lot of cheaped out type of situations, if you don't have a whiteboard, would be to sit down with a pen and paper and map out the logic block of the migration pathways of how things would have to be done based on code. So, if you wanted to scale up, you just look at your whiteboard or whatever, the logic block of the pathways of how things are, and decide, okay, where things should be put in that would activate based on a particular need, and scale things up, hopefully in a logical manner. The introduction of the blueprint kind of changes the idea and the need of actually whiteboarding stuff out, because in essence, a blueprint is in fact whiteboarding in real time. So what you put in actually does have a function and will operate as if you had sat down and plotted everything else in the first place, and then you can scale it up. And if the things aren't working, you can toss it out and start from scratch and do it over again. So in this case, for our project here, Urban Terror, we have various different sandboxes set up, so we can sort of test out, in theory, things that can work, particularly in regards to making the animations look correct as to a particular function or need. We have tons and tons and tons of animations that can be reconfigured for and retasked for a given purpose. But in theory, the level of complexity starts to increase when you go outside a specific design pathway, as in, say, for example, simply making the player run or move. So pretty basic 101 requirement kind of thing you might want to say. So that's where a lot of the tutorials do come into play, to at least demonstrate to you how to make your player move. That's its intended purpose. Things can become a lot more complex when you want your player to do other things during the migration as to a given event, based on whatever input is being introduced into the migration pathway. So if we press, for example, W, the player, in this case, typically the player would move forward. So how does that, where and how does that information come from? Is the starting point of all things as to controlling character input. So that information comes from the input table. So we can actually create a variable, a more or less a global type variable that we can sort of pull the information as to, in this case, if we're moving forward, move forward is bound to the W key. So if we press W, the character moves forward. Now we have a couple of options here, particularly that is once again rather confusing, which to select. So for example, we have action mappings and we have axis mappings. So in theory, moving left and right and forward and backwards can be accomplished via the joystick control as a digital input, and it's simply sampling the directional input as a float value in our axis mapping. So if we wanted to add, this is where we would add that mapping as far as joysticks go. For our needs, though, we're simply using an action mapping, and keep this in your memory, because all things that are attached to our design is based on an action. Now, to kind of deviate a little bit here. At any given point, the player's model's animation can only be in a single given state as to occurrence. For example, you cannot run forward and backwards at the same time, obviously. So as an action event, as far as movement goes, it's considered a locomotion. That's the label they give it. They call it locomotion. Why they chose that, I don't know, but that's just the nature. People like to name things within the development of the engine design that is unique to and obvious for whatever it is that is occurring. So if we push W, locomotion kicks in and the player moves forward. An action state, though, can also be, say, for example, firing a weapon, which is an action state. So you have locomotion state, player moving. You have an action state, what the player is doing while performing the movement or locomotion state, and then layer on top of that other variables too as well. So if you wanted to, you can layer in the player as a progression as part of the migration pathway. The logic block, trust me, we'll get to that point somewhere down the road to kind of explain things, how things are broken up into different requirements as far as layering in or blending in different types of requirements for those particular reasons. So if you have, for example, the need for having a player running while swinging a baseball bat while screaming on the top of their lungs, that all can fit within the migration pathway as an event within the animal graph. And I'll point that out in just a minute, but but to present this idea that input is required, obviously, to begin things and get things rolling, and then the ability to be able to pull that information. Now, another reason why you would want to use an action mapping is if you decide, for example, you want to use root motion, root-based animation, which is an event-driven animation sequence of when an event does occur. So if we, for example, want to fire a weapon, if we press the right mouse button, it just simply samples that as a button that is being pressed. But for the purpose of replication over a network, it needs to sample that the button has been unpressed, and then replicate that across the network as well. So this is just one of the reasons why root motion is not suitable for network play, because, well, for example, if we decide to move forward and we press the W button, we can obviously replicate that the button W has been pressed. But if we don't replicate that the button was unpressed, then obviously over the network the player will still keep moving and running forward and run off into some area of the map that is unplayable and do weird things until of course you press W again, or you press another button that changes the state. So if we press left, for example, in this case move left is A. Unless we release the event by saying, okay, A has been unpressed, the player will keep moving left over the network. So, not a good thing as far as player model control over a network goes. So I thought I'd hopefully pointed it out quickly enough that if you're designing your character control system to work over a network, the use of root motion is not really a good choice for that purpose, as you become responsible for doing all the error correction and releasing the events for each and every one of these event activated key presses. So just keep that kind of in mind. Because our design, of course, for our game means that the player animation has to configure to the demands of network playability. So this is why root motion over network equals bad, because that's just one aspect that causes problems. The task that only adds a lot more work as far as coding requirement goes. Okay, so that kind of explains that. So what's happening here? You can see. Of yet another common problem that I've kind of seen pop up from time to time is the idea that, okay, we have to play 20 questions as to where we're getting this information that is contained within the within the table here. Let's go back to that for just a second and see what we've got as far as inputted action goes. So let's look at our project settings, our input again, and kind of look at this. Okay, we have a fire function as an active event. So normally what you want to do, of course, is pull the input table to see if that event has actually occurred. So in this case, you would go fire, see nothing pops up. So basically, I'm working with 15 here. So basically, you cannot pull the input table from an animation blueprint. So that information has to come from a blueprint that does support the ability to pull the input table as to directional changes, which means, of course, in this case, I'm using, for our purpose, the BP Sandbox character to be able to do some testing. But things get a little bit more complex, and you'll see where that complexity starts coming into play here. But basically what's happening is each time, as you can see, we're watching the delta float time, which is telling us that the event blueprint update animation is constantly cycling through with each delta time tick. So it is active, and it is active all the time kind of idea. So anything that you put within that pathway will be sampled as part of whatever is required downstream here. So this is where casting comes in. we need to be able to get the input information of how the player is, what has been activated as far as controlled input goes. So so in this case, for our test, for just testing purposes, how things are set up for me, I'm casting to my sandbox character, which contains the ability to read the input table. But if you look down here, I'm also casting to the shooter character movement component. The shooter movement component is part of the build of the shooter example, where you initially start off by using the shooter example as the framework that's being able to quickly jump into developing the overall game design called Urban Terror. Another, once again, shameless plug, let's say. So we're casting to the character movement as part of the movement component. Now, kind of talk about this for this little bit here, for example. Okay, first of all, you do not have to play 20 questions. Okay, actually you do have to play 20 questions when it comes to this kind of design pathway, in that you always have to kind of ask what is the current state of a given variable. So for example, as I was talking back before, the player can only be in one locomotion state at any given time. The player can only be in a given action state at any given time. And the third variable that we're concerned about, of course, that can be introduced is the status of the current player model as to things that relate to things like health, for example. Now, based on those three elements, we can refine our animation blueprint so to be able to cast for just a given set of information as far as those three states goes. Is the player, so that kind of information can be evaluated, and by making your sandbox character have more or less a brain, in the same way that we can cast to our shooter character model as to movement relative to the movement component that's contained within that blueprint class. So hopefully this is not too confusing. It really is only confusing until you actually get your hands on it and try it and see what the results are occurring. So in this case, since we do know that our event blueprint update is constant, it's constantly being reevaluated, we do not need to cast for each individual element or a variable from that class as far as input control movement goes. We just have to cast, it's coming in here, we just have to cast for it within a sequence of polling questions. So, for example, is falling there? Okay, so in our sandbox character, we have as part of the navigation movement component of that character, we obviously have a function that determines that, yes, is this character falling or is it not falling? So if we go ahead and select yes, you can see that, okay, there has to be it samples and pulls the character movement component, and from that character movement component, the movement component determines if it's falling or not. So this is the most typical type of function that you'll probably be pulling the movement component for, as in any given instance, the character at any given state or instance, you might want to put it, is in a constant state of falling. It just happens to be resting on the ground as to an object that is preventing it from just keep consistently falling and falling and falling. So if it hits the ground, it's no longer falling, of course, so the movement component is nice enough to tell you, okay, yeah, I'm falling, no, I'm not falling, which is good for network play, because it's the movement component that communicates with the client as to a particular state, and you just let the movement component handle the bulk and the majority of actually how the player is moving within a three-dimensional environment over a network. Now this changes when we're start dealing with root motion, because there's really no way to be able to, except for falling, of course. The player is always falling based on the location of obviously of the capsule, but movement itself is pulled from the velocity of the character based on the input, and then it's that movement of that capsule that is actually replicated to the other clients, versus the root motion being input data that already contains the direction of movement and changes and what have you. So that's kind of getting off into a totally different area, but it should be something that you should be aware of right from the start, because well, if a movement component for root motion is actually introduced at some point down the road, which it would be a pretty darn amazing thing, I mean, network stuff is rather complex to begin with, and I don't want to get anywhere near it to begin with, so to speak. But this is just the input. But what we can also pull for is other information that's contained within this. So firing can, okay. So you can see the difference here between one and the other. Okay, so what we're doing is we're casting to our sandbox character for the information as to movement that is connected to the movement component, which is then replicated over the network, versus is firing, which is an action event taken from our input table here, right here, of pressing the left mouse button. Now, the reason that I think I already explained is why you want to do that is you cannot pull for the action event from within an animation blueprint. So that has to come from a character class or character blueprint class as a means of input. And once again, you can see that within the blueprint, it's active all the time. Now, what we can do then in this case is, of course, start playing 20 questions. You can see that is firing, is what else do we have available to us? Left, move, LEFT. So you can. So there's not an action key event set up in our blueprint to move left from our input table. So where does that have to come from is, of course, is in it from a different blueprint class. Move. Let's see. Do we have? Is it actually in here? Okay. So here are some of the variables that are actually. Okay, let's try is on ice. There you are. Ta-da! So we can cast, so is on ice is something that's been coded into the C++ class of the shooter character movement component, which is not contained in our sample file. Is on ice. See, not there. Okay, so you can have different inputs coming from different classes that can be applied to our anim graph within our animation control file here. So, following this logic, you do not need to have a cast for every and each individual action that you want to be able to take advantage of as part of our anim graph migration pathway. Very important to keep in mind. Okay, so input has to come from somewhere else as part of the animation graph, and you can just tell your animation graph to get that information from a different blueprint class, based on the fact that all blueprints can be made to be operated and active within the framework of the project. You do not need to create 20 different casts for 20 different inputs. Now, to refine that down for our purpose of our design, you can create the input, since we're consistently sampling for this information over and over and over again. We can take this information as a sandbox, as BP sandbox character. Unfortunately, we don't have a cast failed kind of thing set up, but basically we don't need it, because it's part of scaling up the design. We only need to figure out how to make it work, and then based on the logic of whiteboarding, be able to introduce that design into our active character blueprint without well, let's say creating a total mess. Like if we look at this blueprint here, total mess, really. Nice clean blueprints are always nice to work with because you can look at it and follow the logic just as if you're trying to follow a map for a city like New York, for example, and locate things. Now, what we can do, though, is to keep things nice, simple, and tidy, is to convert this information that's being cast for into a set variable, which in this case, if I select this, you can see that the variable type is a BP sandbox character. Now, the reason it's a BP sandbox character is, well, if we go BP, we have to find it. BP sandbox character. There you go. Of course, I have another way of being able to sample from a different variable, but of course I'll probably get out of scope and an out of scope variable error. But in this case, I'm going to take whatever is being sampled through this consistent cycling update and take whatever information is contained as being extracted from this and assign it to a variable class, in this case BP sandbox character. Is there any other options as it relates to this? No, that just kind of puts it in there. So there we have the ability to pull anywhere within our event graph at any time information that we want to extract from our cast from the character sandbox character. Now, to kind of move on forward, this is where things start to get a little bit more interesting of what we're actually doing with that information that we're casting for or pulling for as far as information goes. Now, to kind of stop here for a second here to explain that we're dealing with, once again, the logic and the ability to scale as we start to add different types of animation controls and what have you. And we can just simply, as I demonstrated, pull off this here as to the targets and information that we want to get from a particular class as to input, and create a much really confused type of layout as to input. Now, I'm going to make a suggestion in a minute here or two. Okay, so this is just kind of preparation work to kind of follow the logic and keep updated as to what is actually occurring here as far as progression of concept goes. So we now know that we can get what we need from whatever class that is available to us, because the blueprint is always active, can be made active on the tick, regardless if it's being initiated within the environment or not. So since we can get keyboard sampling from anything, anywhere we want, we can actually create another control type here, which is just contains all the key information that we need to build what I would call an intelligent control system as to the character itself. This here, actually having a brain done by means of ray tracing or line tracing and what have you, to actually become what is usually referred to as object aware. In other words, we can create character models using logic trees and this and that and the other thing to actually make the player model aware of its environment and its position within that space. So it's I think we start getting a little bit more down the road as far as let's say a lot more advanced examples of control systems. You're going to start seeing that player models will have a brain or a logic, similar to the line. I guess you could say that bots, they do have to have a logic of how to be able to move within that environment. Based on simple things that are required, like being about what to do when it collides with a wall, for example. How to make the player climb up a wall, or how to make the bot be able to, say, access an elevator when the necessary information is there that allows it to, say, enter into and operate an elevator, for example. So I would expect sometime in the future you're going to see something, an advanced AI type of bot design showing up on the marketplace that behaves similar to the manner of somebody that would actually be playing the game, as opposed to something that's dumb that doesn't know how to even maybe jump over a wall, for example. So, anyways, that brings us to the idea of how to separate things into functions. Keeping things nice, neat, and tidy, and these are where we're pulling for more information from whatever input that we need as part of the scaling up of our design. As for, let's say, for example, yaw pitch control is based on whatever it is that we're pulling for as far as mouse control goes. So we get control rotation, get active rotation, and make rotator and this, that, and the other thing, and throw it into the pitch and yaw into a variable that we can use for controlling our player model as part of the anim graph. That would obviously become rather rather obvious when we get into that area. But this would be part of the action state. Like, for example, the player running while aiming. So the locomotion is layered. That as an event is layered on top of whatever it is necessary to make the player move. But moving on, this is where we're controlling our keyboard input, and it obviously demonstrates the usability of popping our cast into a variable, but as in that variable is being pulled based on the ability to pull out and let this variable go back to the active event right here of it cycling through the animation each and every time. So if we go to back to our function, let's see where our function is, the keyboard function. So if we go back to our keyboard function, we just put in this parameter, and you can see that our variable is pulling for was right pressed. And you can also, if it's yes or no. If it's yes or no, we're changing the movement state from 1 for left, or left, right, to -1, which means the player will move either left or right, or turning the movement off completely because the button has been released. Now this is controlled within, of course, within our sandbox character. We're getting close to actually popping over there in just a minute. But you can see that as an active event, we're converting the variable to a token value as to a fixed integer value. So it's either 1, -1, or 0, meaning it's either forwards, or backwards, or not moving at all. So this is where we're kind of using the keyboard input to release the event. So where this comes in handy is if, say, for example, something changes down the road. We want to kind of future-proof things. So by changing the movement into a fixed variable value, if, for example, root motion does come into play over network, it would be an easy switch. You just flip a switch, and your root motion now becomes into play without having to rewrite an entire animation graph. So now normally, as far as network plays goes, then our current active animation blueprint that we are actually using for the game is based off of the velocity of the capsule itself. So so the error corrections in the capsule that says, hey, hey guys, I have no forward movement, so everybody stop here. Hey guys, I'm moving left, so everybody else move left. So everything is pulled from the capsule as a ready-made solution that you don't have to deal with this kind of stuff. You just simply have to change the velocity of that capsule within the event graph, or even in the anim graph. So it's kind of getting off the beaten path, but here's where things get a little bit interesting, is the locomotion state. Now remember, we're dealing with locomotion, we're dealing with action event, and we're dealing with current player state as the foundation of how all things should work within the migration pathway. So I'm going to probably harp on that a little bit more because it's going to become a rather important information once we actually get to the anim graph and seeing how everything is kind of flow. But let's look at the locomotion state here, for example. We obviously can pull from anything that we want. In this case, my pawn is where are we? My pawn. I kind of lost where we are as far as that goes. My pawn, I believe, is the movement state of the actual pawn itself. Even though we are actually sending we're actually pulling for and creating a variable for my movement. So this would actually be the locomotion state. Now, where does this come from? Oh well, we're kind of getting kind of deviating. So my pawn is obviously a key. This is coming from the shooter character. I'm pretty sure. So for my pawn, we can sample for the action type event that we created with it and pull for as far as a input from the input table. So if we push W, is walking is a speed, normally would be a speed or a velocity variable, which is converted to a Boolean state. We just need to know is the velocity of the character equal to the player walking, or is it equal to the character running? So we just grab that, and since it's top of the stack, or actually it's not part of the stack, is this goes up here as far as changing the movement state. So the top, if we're moving, I believe our default movement state is running. So the players is always running unless we tell to push a button. I think maybe it's like Q or something. Then the player is then popped into walking mode, which changes the movement state variable to 1. And if we look down further, here is crouching. It would be, say for example, a variable 2, and if swimming would be variable 3, and it's actually variable 4. If is falling, then that would be, well, it's not set to anything just yet, so it's really uncompleted, but you can see how we're changing the state before we even get into the anim graph, which is usually the usual SOP would be, as in standard operating procedure, would be to create entry arguments within a state machine. We're going to change that up in just a minute here as far as how I have things set up in my sandbox, so to speak. Not necessarily ideal as to how things are obviously working within the blueprint, animation blueprint that we're actually making use of. That's the nice thing, is you can do this kind of stuff, and all you would have to do is just change the game type within the world detail panel. Anyways, very important to keep this in mind. We're changing a state based on a fixed integer value. We're not changing the state based on an argument that gets us in and out of a set pathway within the state machine. Okay, so going back, what other information would be important as far as expandability for? Now we have a lot of I should say I have a lot of information here that's just kind of plugged in from various different and set up for the different sources. So for pitch control, for example, this would be if the player is running, for example, the pitch and yaw control is limited to a forward aim, and you only have the ability to use a pitch. If you stop and you're idle, you can use both pitch and yaw at the same time, which is just a reconfiguring, of course, of that of just two variables contained within our anim graph. Okay, speed, I have no idea what I'm doing. Is moving, well, it's either moving or it's not moving. So I don't know why I have added this. I just wanted to actually, I think this is just a global variable just to sample and know that is the player moving or is it not. This comes in handy in the event graph as to saying, okay, if the player is not moving, then ignore ignore the state machine and do the idle sequences that is contained within this migration pathway, which then could be, based on random variables, which means that we can have like 100 different types of idles, and they'll play through randomly for whatever reason. So it's not just the same cycle going over and over and over and over and over again kind of thing. So experimentation. Here we have a movement state that I just kind of threw in is crouching, just to kind of set these variables up. This is just kind of junk that's kind of left over, so it has no purpose. There's no purpose. What is it that is in the control function? It's not even, can't even look at the function. So obviously, by putting stuff into a variable, we can sample it anywhere within the event graph, without having to create 20 instances of this. Now, this is where things get interesting. As I mentioned before, at some point, as your design increases in complexity, you can start giving brains to the actual control input based on its movement within world space and how it should be able to react, and then that information can be just conveyed over and sent over to the animation blueprint based on three variables. We can change as I mentioned, you can only be in one locomotion state at a time. So we can pull directly for this information. It makes sense to do it here because it's easier for, you're not jumping back and forth between blueprints to actually create the type of event that we want. But there's nothing that says that we cannot do this type of calculation of creating movement controls and keyboard input. Where is it? Like, for example, for changing the movement state. So we would have a variable, for example, within the character class that says, okay, I'm moving forward, so change the locomotion state to 1 for running. Okay, so we would just pull or cast to the character blueprint. Okay, what's your current locomotion state? Oh, it's 1. Okay, that's great. Okay, what's your current action state? Oh, you're firing a weapon. Okay, great. Okay, well, what about your health? Okay, well, you're not feeling too good, so we'll have to give you a limp or or a broken arm or something as part of the migration pathway, based on the ability to have that 3 bits of information is available for us. What that means, of course, is since everything's calculated on the character end, our migration pathway becomes a lot more optimized as far as what we have to cast for. And so instead of asking 20 questions, we only have to ask 3. And then we can take that information over into our animation graph and create a migration pathway that is based on the logical progression of that character within 3D space. So let's take a trip over to the Blueprint Sandbox character and see what the heck is going on here. Okay, this is like just a simple cast. I think this is what do we have here? Set size. What am I doing here? Okay, this is just a simple casting test to a line trace test to determine where the player's foot is in left and right feet are located relative to world space. If the player's left foot is slightly over the edge, natural consequences of that is the player will fall over the edge. So this is the things you got to kind of do. Versus is the player actually jumping over. Excuse me, got the hiccups here. Not a good thing. Okay, so if we look at the actual event graph to see what's kind of happening, this is where I'm kind of grabbing this information for, tossing it into a variable. And you can see this variable here as part of a sequence is the player close to an edge. So this actually changes the not to a falling, but rather to a different posture or pose, idle pose, based on is the player moving. So the legs kind of come together in a proper a proper foot together pose that you would normally do as a human being. So if you got a little too close to the edge, your left foot's not going to be floating over the edge, so to speak. So we can reconfigure the pose of the idle state to this manner as part of our atom graph. The other thing that we got here is this is where things get a little interesting. We have animation test action, which pulls of course the input table for whatever the input that is being generated by that key that's being pressed. So 1, 2, 3, 4, 5, and 5 are reserved for being able to do types of flipping of various different types of animation states in real time without having to actually, for example, a death sequence. To activate a death sequence, you actually have to die. In this case, you could just press 1, and the action event is played as a montage, sent over to the animation blueprint as a montage, which we'll get into in a little bit down the road, and it just plays the animation. So you're not really dead, but the but the animation does play out. So which for me as the animator is a good thing, because I can test it without having to actually go through the process that would be required to die. Create self-damage, so to speak. And except for that, you can see that there's nothing in this that is related to anything as advanced as action type of events that are inputted from the action table. But we can pull for it. Move forward. Remember, I was saying that you cannot pull for a input from the input table from an animation blueprint. Can't do it. But we can in a character blueprint. So in this case, you can see here's our input action, and as I was mentioning, we can sample and sample if forward with push, in this case W, and then we could, if we wanted to, if we were using root motion for network, which is once again bad thing. When you push W, we can replicate the pushing of W over the network. But as I mentioned, the thing that input action does that an axis change doesn't do is you can sample to see if the key was released or unpressed. So if I release W, we can obviously replicate that, hey, W was released, so stop, kind of deal. We don't have that types of inputs in this particular class, my sandbox character, because everything as far as movement is actually controlled within our C++ class. So what we can sample for as far as movement goes, of course, is this guy here. It's automatically activated, and we can input and output to this movement component. This is what actually controls the movement of the locomotion, so to speak, of the character moving within three-dimensional space. So is the player falling? Is the player walking? Which is based on velocity? Is it turning left or right? It's simply contained within this movement character, which we can sample for that variable down here somewhere. So all this stuff here, as to say, for example, jump Z velocity. If we wanted to, we can cast for that information. We can even send it back and set this variable from within the animation blueprint. So we have at least some degree of controllability over how the capsule would actually move in a given instance. Like, for example, is the player running or do we need the player walking? Which both of those are based on velocity, so to speak. Okay, so do we have anything here that we can just kind of take a look at? I won't get, okay, for velocity, there's some information about a velocity. I won't get too much into this because I'll need this stuff here is network stuff, and I generally use this, I generally avoid doing anything that's sort of moving into the coding turf, so to speak. And, it's not a good thing to mess up their stuff, trust me. Ledge climbing, it's kind of interesting because looks like there's some stuff that's been added. I don't know if this is part of the update. This is actually kind of interesting. I never noticed this one here before. Ledge climb speed, ledge climb exponent. I don't know if this is something that's new, or if it's something that we simply added to the class. I'm using the BP character class, which is the parent for this. So anything that the coders have done to add to this will obviously translate into this. But that's kind of interesting. Wall jump. Interesting. I never noticed that. Moving, walking. This is where the actual character can be able to move, run, walk speed, crouched. Yeah, this has been modified, I think. But anyways, this is what we can cast for as far as what we want to be able to do as far as locomotion goes as part of our animation BP class. Okay, so this kind of brings us to where we need to go. How is this stuff comes together as to an action that actually pertains to character movement? Now, once again, keep in mind, it's not the player that's moving. Unless you're using root motion, it's actually hot glued and bound to whatever it is the capsule is doing as far as moving within three-dimensional space. And it's simply, what we're simply doing is we're creating a puppet in a box type of reaction to that, whatever happens to be a particular class that's been, or a particular event that has been triggered. And the most ideal way to do that is to avoid input and output arguments, nesting input arguments within, say, for example, a state machine. Now, that's not to say it's a bad thing. It simply means that, unless you have some really basic animation requirements, a state machine is not really suitable to the idea of being able to scale as you want to start to add stuff. So I'll mention that now because this is where things start to get interesting. If we look at our animation graph, in my example, I don't have a single state machine within the migration pathway. That's because everything is done based on integer or Boolean reconfiguration of the pathway. So if we look here, as we're talking about logic blocks, this here is where the logic of locomotion occurs based on the change of our movement state. So if it's run, right, okay, movement state wise default is 0, which means that our movement state will always be run rifle run. I gave it a suffix of NC. I can't remember why I did that, so we'll stick on pathway here. So the first thing it does is it goes in and it goes into a rifle run, which when we then, of course, sample the direction and speed changes of that direction based on the velocity, obviously, of the character. So it runs left, right, forwards, backwards, and it turns and what have you. Is everything is then, of course, if this is default to 0, then the player will obviously do that perform that action. If we change the movement state to 1, then that's walking. So it'll go through this migration pathway. If we change the movement state to 2, then that's a crouching state. So that's this is where this information comes into hand. Now we also have a Boolean type of selection. Remember when I pointed out that within this class here we have a kind of a set thing here set up for testing, and this translates into adding to the idea of scalability. Okay, so we have a need here. Basically, the player's looking over the ledge. It gets too close to it. We have to change the migration pathway is moving, and that comes down into here. Changes the movement state to idle. And if it's close to the edge, as far as a Boolean goes, it changes once again the idle state, turn state, from left to right versus just standing in a general idle pose, holding a weapon and kind of moving around. So this is all kind of part of this section here is all part of the locomotion state. Now, another part of the locomotion state here too as well, based on Boolean, is an error. Takes us into what we need to be able to make the player jump. Now this, in some ways, looks like a state machine, but it's not. As we don't need arguments to get into and out of a state change. And blending, in this case, as to moving from one state, as into, say, for example, running, to walking, to crouching, is handled by the blend time contained within a posed by integer. So this posed by integer changes the migration pathway based on our fixed variable of our movement state. So blend time, and then it looks at the blend time as either a fixed value or as a variable that we can input into that, and we can change the amount of time it actually does take to go from one state to the other. Now this is usually an interpolation of X number of frames, be it wherever it is within that cycle. It doesn't matter where you are within that cycle. Now usually to get out of a cycle within an event graph, usually you have to use a statement that if there's like, to make sure that it kind of lines up, is you have to use an argument, is there 10% left on the animation left, then blend into the next cycle. In this case here, wherever the animation is within that cycle, it's going to blend into the cycle that we're telling it to go into. So we will run to a walk, our blend time is right there. If we're going back to a walk, then our blend time is there. The actual blending of this cycle, say for example running left and right and what have you, is actually controlled by the blend space. So you can change the ease in and ease out of the action within the blend space itself. So this actually has this almost the identical type of ability of blending within a state machine, but you have to kind of build that ability from the little bits and pieces that you have available to us. It's not a bad thing. You have to do a little bit more work, but it's not that bad. Then we have blend poses by Boolean. Of course, we can switch pathways from one to the other, as I mentioned. If we get too close to the edge or what have you. So that's all contained within this here. Now, of course, we follow through the migration pathway, where that brings us next to another layer per bone. Now, this is where we start dealing with action states. This is, once again, as I mentioned, is a locomotion state. You can only be in one locomotion state at a time. So what do you need? You just need a variable that says, hey, this is what I'm doing at the moment. So as for moving on to an action state, for example, aim offset, aim offset is part of the upper torso action state. So locomotion over into action state as part of the logical migration of our animation state, our animation graph, I should say. Okay, so what do we have here is we have rifle offset, we have pistol aim offset, we have two-handed aim offset, and these are triggered basically by genetic weapon selection. Now this is where things get a little bit, let's say, we have kind of something that's been introduced into the loop that's a little bit more difficult to explain because you can't see it. And since Urban Terror has a lot of weapons, eventually we could have dozens and dozens of different weapons. The action states have to be based, for things like aim offset, has to be based on weapon, has to be weapon orientated. So the information that we have to pull is contained within the weapons blueprint as to proper positioning of things like hands. Is the weapon being reloaded specific to that weapon? Comes from a different place, and I won't go deviate from there, except to kind of point out where that is being introduced into our anim graph. So aim offset is just generic aiming of the character. It's just it's nothing fancy about it. It doesn't matter basically what it is that you're holding. You can switch this out. We're just switching this out by weapon class type. It just makes it easier at this time to actually get the proper hand positioning without having to do something fancy, which we have to deal with later down the road. Once again, we're talking scalability here. We're talking a concept. We're not talking about this is how you have to do it. And in actuality, this whole layout so far we have here is going to change. It's a given. It's my sandbox, remember? Okay, so anyways, the aim offset pitch for rifle, offset for two-handed and what have you is contained within within a 1D blend space. It's the same thing for pitch. Now, the reason I did this is it becomes easier to, it's a cheat, okay? You know, it is a miserable, okay, one of the nature of Unreal 4 is everything is interpolated that you put in as far as animation goes. You know, I don't even want to start talking about lip sync. And it takes a different type of approach than you normally would have to take if you were doing it for rendered for something that's for say out of app rendering. So everything gets interpolated, which causes some weird, wacky things to occur. So in this case, to solve that problem for the end space offsets and what have you, I'm just using a 1D blend space with, I think it's something like 24 separate frames within that blend space, and each is posed as an absolute. So if it goes from one frame to the other, to the other, to the other, there's no room for interpolation to occur, which usually results in the weapon type of separation from the hand. Everything is hard coded. Now that's probably changed, I think, in the meantime, but this is the way it still works, and it works great. And I found that separating the aim offset into 1D for pitch and yaw is a good way of doing this, because you can then use this to kind of switch for idle state versus running state kind of deal. And it's actually pretty cool. Is that you can actually be there's a fancy word for it, but basically when you're standing still, you want to be able to have the player pitch and yaw, and then match that up with feet. If you reach a certain degree angle, the feet actually turning the player as it turns around. So it looks pretty cool. But what also looks cool is if you're running, we can easily flip from a locked pitch, or I should say a locked yaw, to turning the yaw back on, so you can be aiming while running. So it takes a little bit of practice to get used to, but it's actually pretty cool. Now that's that. Once again, here's our magic switch, so to speak, of where this information goes as far as the player model being able to have the player running, not only running, but doing things like running and reloading and firing and picking their nose, or whatever it is that we want to separate as part of the layering of the player's action, without having to build that or actually authored that type of animation. It's a kind of a waste of space to have a running animation, and a running animation of the player firing, and a running animation of the player reloading the weapon. That's a rather inefficient way of doing things. So the smart way of doing things is just to layer it on top of the bone. In this case, if I select this bone here, I think you can. Our blend target is the admin. I'm not even going to try to pronounce that. Lower, blah blah blah, with a blend depth of about 5, which allows us to translate upper torso movement as far as the run movement. And what else do we have here? Nothing else is really important. But the cool thing about this is we can add elements to our branch here, as to say, okay, I want this to be applied to the hips. I want this animation to be also applied to, say, the left arm only, as part of this layering, and then that just affects that and gives us a higher degree of control without having to duplicate animation sets. This brings us over. This is actually the better example. This is a test. Our player model designs, they can talk, they can express, they can blink their eyes, they can do all this type of stuff. And the question is it really necessary as part of our game design? No, it's not. It's just that we can add, this is how we can add it as animation that is authored and connected to the character model to begin with. So this impression set is based on the character being in the T-pose position, or A pose, depending on what we need. and it's simply layered on top of for the facial expression. So in our migration pathway here, just to kind of back up a bit here again, so we're going from our locomotion state, and we're layering in our ability to aim offset whatever weapon we have. And to top that off, we add another layer here for facial expressions or dialogue or talking or radio calls or whatever it is, just as kind of a goof kind of thing. Firing animation is firing. I'm not too sure what the heck we're doing there, but as you can see, there is no connection to this as far as the logic pathway goes. I think that is actually triggered as a different direction somewhere in here. Sometimes you have to relearn stuff. That's just a problem having something messy and mushy. Okay, so that moving forward, this takes us to the end of the line here. Now, remember we was talking about whatchamacallit, talking about, where are we? Where's my brains? We are talking of, what are we talking about? We are talking about montages. Okay, so this is where a montage is introduced into the pipeline as a layered blend per phone as a given event. So in other words, remember when I was mentioning that urban terror is weapon space, which means that the information contained as to the information that has to be conveyed to animations for third person and first person is contained within the weapons package, has to be sent back into our animation graph as a montage, in this case into our upper body slot. So if the player is firing an Uzi, this is where it comes in. If the player is firing a sidearm, this is where that animation comes in. If the player is, did I say reloading? Okay, well anyways, reloading a shotgun, this is where the animation comes in and conveyed from the weapons blueprint into the migration pathway as a per bone layer, as well as a layer off of the base pose that is within, of course, ends here, I believe. Yep. Okay, and that takes it in forward. We then I think we have another slot here for whatever reason I can't remember. We're doing some testing here. But anything that is activated after the per bone layer affects the entire player model. So I obviously did that for some kind of testing or what have you that had to be an absolute animation. Then the output finally goes to our final animation pose. Now, overall, this is actually a very simple design once you understand how the flow can be reconfigured without having to make use of a state machine. Now, not recommended that you don't use a state machine, but you should get some consideration as to what it does. What is its purpose within the migration pathway. 9 times out of 10 you don't need it, because you can create a variable that is an absolute, meaning that no matter what, this is self-correcting. It doesn't matter if you push a button and all of a sudden your animation starts doing funky things and you got to start troubleshooting. 9 times out of 10 you're going to be drilling down into your state machines to figure out what variable is not releasing it from that, to get that state within the state machine within the anim graph. It's kind of like pushing a horse instead of trying to pull it, kind of thing. Putting arguments within a state, within any kind of state variable that has to change, it's not really a good thing. It's not healthy, because it can get buggy if the variable state gets buggy, so to speak. In this case, going back to our event graph, going back to our locomotion state, was it? I think it was a locomotion state. It can only it will you release a key, it has to default back to 0 every time, which is our default is running. So, or is the player actually moving? No, it's 0. So it doesn't need you to, within a state machine, ask, hey, are you moving? Because you can never really know. Anyways, I think that should be enough to at least illustrate that, when you ask questions that, hey, why is this not working? It's a lot more complex than you actually think once you start having particular needs as to a given event that has to occur within this atom graph here. And as you see, there's no arguments that are going on in here whatsoever except for sampling whatever is true within the event graph. So hope that's enough to at least be a little bit more informative and a little bit more dangerous, so to speak. But give it some thought. Don't just look at take whatever tutorial that's being presented as granted, because player model control, especially if you're looking to do the next Assassin's Creed, is it's very, very complex. So as I kind of just pointed it out by a general chit chat, so to speak. Okay, talk to you later. See you guys. Bye. Oh.